Today we are going to talk about elementary calculus. Well, I call it elementary calculus because calculus is big and there's so many different facets of calculus, but they are all built upon the concepts that we'll talk about over here. So the first concept in calculus that you have to understand, and this you have to really understand, it's the concept of a derivative. But when I mean to understand, I don't mean like to really know it. Well, you need to know it, but let me explain it in this way. There are two ways of understanding math. There are people who understand math when they are doing problems. And there are people who has to understand where is this coming from? How is this related to my life? What does it matter? Does it mean like I'm not going to make it in life if I don't know calculus? Something like that. But for me, no longer, because I'm trying to show you some of the things. I have to explain everything that I do know. So, but I know there are people who don't like, you see, if you look at this paper over here, there are too many words. There are people who are ready to do problems, who are always ready to do problems and solve problems, and they don't really need to understand, like, what is calculus. They know how to apply it and solve problems. And since calculus, it's a tool, so they know how to use the tool whenever it's time to use the tool. They don't really need to know like the history of the tool, or sometimes even not even the name of the tool. They just know how to solve problems. Okay, let's continue. Now, elementary calculus. Over here, I say elementary because we start with them at the basics of calculus, the limit theorem. And then after the limit theorem, which is the same as a derivative. So, but we have to make a connection with okay, how does it come from being a limit into a derivative? So now I put this stuff over here. If you can write it down, you can write it, but this is important for your exams though, because as I have looked at matriculation exams in South Africa, the way they write a derivative, they write it in different ways. So this sign over here, d sub x or dx, they will put the dx over here, and then inside of that, let's say they will say dx over here, and then give you something like x squared minus 4x, and put it like this, and then say solve. You should know that this stands for the derivative. So it means that you should take a derivative over here. On this one, because I already started it, I'll just say 2x minus 4. That's the answer for this. Don't worry how I got there. We'll figure it out how I solve this. And then sometimes they will use the sign d f of x over dx. This means, okay, let's start with this dx. This is the derivative with respect to x. So you take a derivative with respect to the x variable. You will see what I mean. Okay, this one again, it's the same. Sometimes they use that symbol, sometimes they use this one, df of x over dx. We're taking a derivative. F of x is the function, a derivative of the function with respect to x. That's what this means, df of x over dx. Or sometimes they will give you f prime of x. That is a derivative too. It's the same as this, it's the same as that. This one we call it f prime of x. And then the last one would be, if they say solve the limit as h approaches 0 of f of x plus h minus f of x divided by h. These are all the same thing. Like this is a derivative, this is a derivative, that's a derivative, that's a derivative. So if they give you all of these, you can go ahead and use the way I will show you. So now, here we come. What is a derivative? Okay, my small explanation over here. It's like, well, this thing over here, take it as a mountain, like a mountain in Zaba. And then on that mountain, I put coordinates over here. These coordinates are the XY coordinate. One day you will learn about coordinate systems as you do calculus, because in calculus, everything is based on the coordinate system that you are using. Now we're using the XY coordinate system. So if you put an XY coordinate system, this guy over here is climbing a mountain. Now, what is a derivative if somebody is climbing a mountain? Now, you know, if you are climbing a mountain, kuna sections that are very steep in a mountain, and then there are sections that are less steep, and there are sections that are even vertical in such a way that it's impossible to go up the mountain. So a derivative is taking a slope at an instant in a position, Let's say a slope over here. This slope here will be different than the slope over here. You can see the line that I'm drawing. It's different. And then it will be a different slope over here as well. And then it will be a different slope over here. So the idea of a derivative is that we squeeze that little area and make it really small as h, like whatever you are climbing over there, approaches 0, like really, really small. So at that instant, we want to know the slope of that. Because why? If we say we take a slope of the whole mountain here, it will be an average, because the slope is not the same everywhere. So people always want to know the slope at an instant. And then now I use the slope because, look at me. We're using the slope in terms of y. So it's like you're taking a derivative of that instant in terms of y. Y is the distance that we are traveling. So P over here, we will take a slope of P over there. That we will call a derivative. It's change of y over change of x. In other words, we squeeze that into smaller and smaller fractions and we say dy over dx. We're taking that slope with respect to the x section. So that is a slope at an instant position. Usually the function is written as y equals to something. Any function is written as y equals to something, or it's written as f of x equals to something. Therefore, based on that, when we're taking a derivative, we use dy over dx. df of x over dx. This is the derivative of a function with respect to x. X la is a position. Now, there are other derivatives that you can take. Like, let's say acceleration equals to dv over dt. So now, Acceleration is change in velocity over change in time. But now, if we squeeze that into small fraction, we want to know the slope at that instant. We call it A equals to dv over dt. Now you can realize ukuthi lo dt lo akafanani nalo dx lo. So now we're going to do a derivative of velocity with respect to what? To time. That is how it's read over here. And a velocity on the other vein will be a derivative of, you can use x. We can use x over here over time. So now, you see now you have x at the top. Over here you had x at the bottom. Now your x is your position that you are looking at over time. So now, if you were given something to solve as a function over here, you don't solve it with respect to the x, you only solve it with respect to the t. Now, this is a rudimentary introduction. It will all make sense when we start solving problems. I will try to make problems where you have different variables so that you can see what I mean by the word with respect to, because I know some people will be like, what do you mean with respect to? Respect in English is defined differently than respect in math. So don't use English terms usually in math because sometimes it will throw you off. But as we start solving problems, you will see what I mean by this. And I will come back to explain it, what I meant by it, and then you will see what I meant by it. All right.